Welcome back to this first cool talk after the summer breaks on distributing Docker container applications. This is actually a very appropriate topic for this comeback, as it is a continuation of the very first cool lecture that we had in last October, where Armin Hemel and Carsten Emde talked about the challenges that you are presented with when distributing Docker containers. And I remember quite well that we had a very lively discussion on this topic after the talk, and a lot of ideas came up, and we took up some of those ideas because, as you know, OSADL isn't happy to only present you with problems, but we would also like to give you at least a part solution for those problems that we talk about. And therefore, from this last cool, a legal opinion ensued that our General Counsel, Dr. Till Jäger, created on Docker containers. And from that legal opinion, again, a OSADL project was created that I am happy to present to you today. The OSADL Docker Base Image and how it can help with compliant container application. First of all, though, some of you might have seen the cool lectures last October, or you might have watched the online recordings of those lectures, but I would still like to take the opportunity to repeat some of the basics. This is, after all, the basic lecture, so that we all know that we're talking about the same things. Saying that, we'll start off with some definitions. So Docker containers are based on virtualization of the operating system application level. This technology has been around for many, many years, but more recently it has been made popular again by the company Docker and their implementation of this technology. Now, Docker is as I said now, it's the name of the company that has made this technology popular again, but it's also used for different aspects of a container. So we'll just talk about some of these terms and what they actually mean. So a Docker container, or a container in general, usually describes a running instance on a machine. This Docker container is created from a so-called Docker image or container image, which is the representation, the collection of all of the software on disk. So that is the image, and from one image, several containers can be created. Now, a Docker image can be created manually, or it can be created from a Docker file. A Docker file is a list of instructions on how to assemble the image. And the actual machine that does the assembling and that also does managing of Docker images and Docker containers is called the Docker engine. That's the layer between the operating system and the various Docker containers. So this is all meant when we talk about Docker, but usually it becomes clear from the context if we're talking about containers, images, or the Docker engines. And of course, Docker files are always called Docker files. So that's quite clear. Now, what is a container actually made up of? What does it look like? Or first, before we look into this, why are containers so popular? I think this is well established by now. All dependencies, all data, all configurations are contained in an isolated environment. This makes distribution and deployment of software a lot easier, in particular because with more and more complex software ecosystems, compatibility is a big issue, And if different applications, different functionalities are grouped together in separate containers, then compatibility issues between those containers can be avoided. A system can be frozen the way it is in production, and then it runs exactly the same at the recipient's end. So this really makes life a lot easier. There is one downside to this aspect, which isn't talked about a lot, and which it is probably too late to be fixed now. But I think considering that we'll try to look at different aspects from different directions and try to judge them critically, we should at least mention this downside here. And this is in particular that this possibility to freeze a system in a particular state also removes any obligations to work within the bigger system, to work within, for example, a package management system of a distribution, or even of several different distributions, and of course in that context also stay updated with updating the distribution itself, because the Docker image just stays frozen in time. And this freezing does of course also have downsides, in particular if no updates can be applied, then security issues might arise that otherwise could be fixed. So this is all a downside as well. It makes life easier, but easier life means less work, and some of the work is something that would fall onto this aspect. So just something to consider when using Docker containers. Now we'll get into how a container image is actually made up. So we have stacked layers that contain different components, usually different layers group different functionalities and modifications. And for example, this could look like this, with a base layer on top. This is general what happens. So this contains system requirements, a C library, a package manager, a shell, networking functionalities, and such. And on top of this, we have applications and their dependencies, like libraries. And on top, there might be much more layers. But just to give an idea, to do some customizations of the container image can happen in a third layer, like removing some components and modifying others. So to just have a look what this could look like, we'll imagine a container layer with different components here. So we have the base layer. This might be a package manager. There might be a shell in here. There's some system libraries and such different components that literally make up the base of a container. On top of that, we'll add some files. We'll add additional applications, maybe one application and one library that this application needs in addition to the system libraries that are already available via the base image. And then in a third layer, some of the existing components within the container might be modified, and maybe some of them even deleted if they are not required at all. This is the container image. So we have different layers within this image, but if now the container is started on the machine, this image is run and a running container is created from it, then this kind of shrinks together, it folds together, and what we see in the end from a running container is only this view from the top. So it's only this view from the top with these different components that are available in the base image and that were added by higher layers as well, including the modifications and the removals. But as you can see here, as is indicated here, the other components that were removed or modified are still available. So the removed component and the original component are still within the container image and are distributed along with it, even though they cannot be seen from the running container. So this is a picture that it's worth keeping in mind, that you have a top view, but there is a lot more content within the container that cannot be seen. Now we'll talk about different components, different software components. What are they actually? Well, as with a lot of software nowadays, most of it, or at least most of what you'll have in a base image, for example, is free and open source software. So I don't think you can build a container, or hardly any containers exist without any free and open source software. And of course, this is something that you know and that you hear a lot from us. When copying and distributing FOSS, then license obligations have to be fulfilled. This can be very different obligation depending on the particular license that are involved, but in general, the general different types of license obligations that have to be fulfilled are, for one, information obligation, meaning license texts, copyright notices, legal notices, warranty disclaimers, acknowledgements. So a lot of textual information has to be delivered along with the software. There's disclosure obligations, so some licenses require to disclose source code, some even require to disclose build instructions, and here it's important, it is the complete corresponding source code, so not any source code, but the one that's actually for this version, which is available within the container. So here the modification aspect has to be considered as well. And then we have licensing obligations as well. So whenever open source, this is not specific to using Docker containers. Whenever open source software is distributed from a company, company documents have to be adapted to account for open source licenses. And if own development forms a derivative work with software under a copyleft license, then licensing of own development has to be considered as well. So these are general aspects that should always have to be considered when distributing free and open source software, and should anyway be part of a company's processes. But now, what is particular about Docker containers again? So what's the challenge of Docker containers if we consider these obligations? Well, thinking back on that picture on the view of the running container, you can see immediately that it is not obvious what software is actually distributed within the container. Usually if you have a product, you know what software components are in there, but with a container you can't see anymore. But we're talking about copyright, and copyright is not the same as, for example, patent rights, where patents only become relevant when the technology is being used. But for copyright, the act that activates the requirement to fulfill license obligation is copying and distributing. It does not matter at all if the software is visible at all or if it is ever being used. So just alone the fact that it is copied and distributed requires license obligations. That means that license obligations have to be fulfilled for all software components that's distributed, even if it is not visible at all. Now, you might say it's easy if you build a container image yourself, then you know what's in there, and it doesn't. You know, even though you can't see it from top, and you can fulfill license obligation for all components. But you might get container images from online repositories or from suppliers or from wherever else, and you're not sure what's inside the container, and then because you only have the top view and you don't have don't know what the image is actually made up of. So then we need tools to look at these images, and we need processes we we need possibilities to make containers generally compliant just when they are downloaded from the internet. The tools we'll get into in the advanced lectures today. Armin Hemel will talk about that. And going on from here, we'll talk about creating license-compliant containers. So the second challenge with containers, and I've mentioned this now already, is that public container repositories do usually, and not even often, but really usually not provide any compliance information. So you can, a lot of them are, for example, on Docker Hub. You can pull a container onto your system and you will not get any information about the software that's contained within, the way the image is made up, or how you can get the source code. But saying that the original provider of software does not fulfill any license obligation is unfortunately not an argument if you distribute a container, then, or for software in general, then you have to fulfill license obligations anyway. So it's important to, when introducing software into the company that is intended to be copied and distributed, to make sure that it is possible to fulfill license obligation for that software. And this is unfortunately for containers often not the case because the repositories do not provide any such material. So this is the challenge that we are faced with. Now, what about Docker files? Docker files are scripts from which a Docker engine can assemble a container image. So it's just a list of instructions. Many of those are download instructions, and the Docker engine will then create an image from that from which a container can be run. Now, the obvious idea here is, or the first idea that one could have is that, oh, well, I don't distribute a container image, then I just give my customer a Docker file and they will run it on their computer. All the software is downloaded locally for them, so I don't distribute any software, I don't have to fulfill license obligations. Well, unfortunately, that doesn't work because of there were several court rulings on that, and the fact is that it's the definition of distribution within copyright law, and distribution is defined in such a way that the person who controls the distribution is also responsible for license compliance. Controlling the distribution means deciding what software is being used, how different components work together, and not giving the recipient a choice of what parts to use and which parts not to use. So giving away a Docker file which has the separate instructions scripted and is clearly a way to control the distribution of the software that the Docker engine downloads according to this Docker file. So what we end up with is the fact that distributing a Docker file is exactly the same as distributing software where license compliance responsibilities are concerned. And this is where we ended up last year in October, and this is where we started to go on with work. So we've asked our general counsel, Dr. Till Jäger, to take a closer look at distributing Docker files and tell us what to do about this. So this interpretation or this definition that the distribution of Docker file is the same as distributing software has already come out of this legal opinion, but then we'll go on and see what we can do with that. So the difficulties, I've mentioned them, those are clear. We have the difficulties that repositories do not contain compliance material, but there's also the additional difficulty that commands in a Docker file may point to different software at different times. For example, if the version or the tag latest is specified, then a change in the repository leads to a different software on the machine, on the local machine. Now, what has come out of this legal opinion is a possible exception that could help us with license compliance here. And to give a bit of background, we'll again look at normal software, not containerized software. So if you distribute an application that is meant to run, for example, on a Linux system, then you only distribute the application, you do not distribute the Linux distribution, then a FOSS license of the application does not require any license obligations to be fulfilled on the operating system that it is meant to run on, for example. So this are quite two different things. So the same goes for container images. So if you distribute a container image, then you do not have to fulfill any license obligations on, for example, the operating system or the Docker engine that this container image is meant to run on, even though only a container image without any underlying software is completely useless. But this is something that where there is a limit for FOSS license compliance, so they don't involve this. Now, container images are made up of a same kind of stacked layering. So we've seen before, we've had base images. For basically every container is based on a so-called base image. And these consist of essential system requirements and system libraries. Now one could ask oneself if this exception, which goes for operating system, which goes for Docker engine, could also be extended to base images. And the legal opinion concludes that this is indeed the case, and that therefore no license obligations apply for a base image which is distributed via Docker file. Of course, same as with a Linux distribution, if you distribute the software itself, you still have to fulfill license obligations. But if you if you have the command in a Docker file that says from base image, then the license obligation for this base image do not have to be fulfilled. So that would make life a lot easier. But there are still some conditions on this base image for this exception to hold. And one of these conditions is that there are no modifications to the base image, which is usually not a problem because modifications are put on higher layers, so these can be undone again. And the second obligation is harder to fulfill because the base image originally has to be offered in a license-compliant way from the specified repository where it is downloaded from. So we have license-compliant way, and as we've mentioned several times now, public repositories do not offer license-compliant or do generally not offer license-compliant container images. Now this is where the OSADL legal opinion or Dr. Jäger's legal opinion concluded, and this is where the OSADL project started. So we've taken the idea of OSADL to develop base technology in a community and to develop services to use open source software also in a community. We've extended this to Docker Base Images, as it is already in a word, it's a base technology. So we've created the OSADL Docker Base Image for compliant container distribution. It's a minimal image based on a Linux distribution. 3 variants are available as of today. They contain essential GNU tools, they contain a shell, a C library, a package manager, networking functionalities, and really not much more. But in addition to this base software, which you'll get on any container repository, you also get license compliance material along with this base image, meaning the source code of all packages, license text, extracted legal notices, and rebuild instructions, how it is required. Now, the OSADL Docker Base Image, I will quickly talk about some of the steps, how this is actually created. So it's actually not that hard to create a Docker base image. The important steps are later the compliance steps. So an initial installation starts with just creating a directory for a chroot environment and install the base image into it. Depending on what the base distribution is, this works a little differently for everything that's based on Debian. So Debian, Ubuntu, and all those different flavors of Ubuntu and Debian can use dbootstrap on an existing Debian system to create this initial base installation. Alpine, for example, and a fairly popular, because it's very small, so it's quite a popular distribution for Docker containers, uses a statically linked version of their package management system, APK. So once this basic installation environment is created, we can do a setup. So you can change root into this installation, into this directory, add source repositories, set up name servers, and do some customization to the image as you require it. And then the compliance process starts. So first of all, sources have to be downloaded. Using the package manager, this is fairly simple. So all installed packages, their version, important, their version has to be listed and then downloaded the corresponding source packages. So these steps can be scripted very well, so it goes quite fast. It's a little bit more complicated with Alpine than with Debian, as the package management system is not as straightforward. So once the source packages have been downloaded, the chroot environment can be exited again, and the sources are then exported and unpacked, patched, and scanned with your favorite license scanner. Of course, to create all the compliance material that is required, extracting license text, extracting license notices, copyright notices, acknowledgement, warranty disclaimer, and so on, to create a legal information and license compliance material for this base image. To consider information obligation, of course, a little text has to be created. OSADL usually offers template text for those that you can find as part of our FAQ. And this text that gives some hints that open source software is used in this product, that where legal information on this software can be found, and conspicuous notices that some licenses require, like for example the warranty disclaimer of the GPL. So these kind of informations are mentioned in the legal information, and that has to be created and then maybe even displayed when starting the base image, the container. And then finally, once all of this material has been created, has maybe even been introduced into the container, into the chroot environment, then the container image can be created and imported into the Docker engine. So these are just the basic steps on how the OSADL base image is created, and how you can also create your own base images if you would like to. Now, the OSADL Docker Base Image is available in two variants, I say. So each version is available in two variants. One of them being for immediate source code delivery, and the other one for delayed source code delivery. So immediate source code delivery, as is given, for example, by Article 3A of the GPL2, where all source code is included in the container image itself. Also, a little note with the legal information that I mentioned before. And because all of this is included in the image, so you only have this one image file, it is also available on Docker Hub to be referenced in a Docker file, for example. And then you can also get the image in a form for delayed source code delivery, where the extracted compliance material is contained within the image, also a note with legal information, and a written offer for delayed source code delivery. And then the source code itself, so the source packages plus rebuild instructions, are provided separately so that they can be delivered later on request. Now, instructions on how the base image is created, more detailed instructions than I've shown here, and how it can be used, how you can get started with it, are also given in each case with these two versions. Now, just to give a quick overview, so the base image for immediate source code delivery is clearly larger, considerably larger, because the source code is included in it. The base image for delayed source code delivery is smaller. It only contains extracted compliance material along with the legal notice and a written offer, and the source code is then delivered separately. And the instructions on how to use and how to build are included as well. There is some information, some general information on the project available at OSADL.org base image, as well as the base images themselves for download, for if you have a member login to the OSADL website. If not, let us know and we'll create one for you. So as of today, it is available as an Alpine version 3.14, Debian 10 Buster, and Debian 11 Bullseye, all of them for x86 architecture. If any additional variants are needed, if you would like a different kind of, maybe a Ubuntu-based container or a different version of any of these, please let us know. We're happy to create more of them and make them available on request. But so far, this is what we started with and what was requested so far. So this list might grow. Now, now we have the base image available now. And the idea of this base image is, of course, to be able to help building compliant container applications on top of it. So you would start with the OSADL base image and then customize it to be of use for the use case that you would like to, or for the product that you would like to distribute. And to exemplify how this could work, how this would go, we took a little example application, which is the Hello World program of the Immediate C project, which you can read about on the OSADL website or on GitHub. It's a little program to write software for industrial controls using the language C. The build process is via Docker file, so we'll start on the Docker file with the base image and then build the container, the application on top of it. Now let's have a look at what the Docker file to do so looks like. Now this Docker file is not complete, but it gives some ideas. So you can't copy this one on one, but more or less this is what it would go like. So we'll start in the first step with the OSADL Docker Base Image Debian Buster version 1.2 binary only delivery. Then in the second step, we use the package management system to install additional packages, dependencies that the application will require to build and to run. The third step installs additional dependencies, but these are not installed via the package management system, but independently downloaded, built, and installed on the system. Then finally, the main part, the application itself, is downloaded and installed. And afterwards, a few customizations are taken. The configuration of, for example, here, the SSH is changed, and the user or a root password is created. Finally, a few things are deleted again because they don't need to be visible in the final container. And the entry point, last but not least, the entry point is specified, so what the container should do whenever every time it is started. So start the SSH client, print out the IP address, and start a shell. So here we see every single step that is listed in this, every single line, so every new command that is listed in this Docker file will create a new layer on top of the OSADL Docker Base Image. So this is our base layer, and then every command creates a new layer. So in the end we have 1, 2, 3, 4, 5, 6 layers on top of the base image. And here you can see now very well that the second to last layer will remove some, just in this case, just some archives which are already extracted as well. But things that are removed here are still available. They are still present within the container. You just won't be able to see it in the final running version. So after we've now created this Docker file and then written it, we'll see what happens when we build a container from it and run the application. So of course we'll start at the very beginning, namely by getting the OSADL Docker Base Image from the OSADL website. And as you can see here, I'm logged into the OSADL website with my member account, and when I scroll down here to projects, I can find the OSADL Docker Base Image. And there are several versions available, as I have mentioned before, and we're using the Debian base image, which you can download from here when you are logged in. As this takes a little while, I have already prepared it, and we can go and look at the archive, which is available here. We'll extract it. And then have a look inside this archive as it is downloaded from the OSADL website. So this archive, as you can obtain it, it contains a few documents with information on the project in general and on this particular version of the OSADL Docker Base Image in particular. And you can see 2 directories for binary delivery and for delivery including the source code. So just to give you an idea, what all of this actually contains. Let's have a look at some of the documents, just so that you can see what kind of information is included with the OSADL Docker Base Image. So this is really the where everything started, so how a base image can be created. So if you're ever in the position to create your own base image, then you can use these instructions. They're available for Debian and for Alpine, just to give an idea what this image, how this image was created. Then there is some information on the content and on how to get started with the base image. In the How to Get Started document that tells you on how to unpack it, how to load it into the Docker image, and also what packages are contained within this minimal base image. And last but not least, this is the same information that's available on the website. You have just some general information on the project and on the contents and on the background of this OSADL Docker Base Image and of this complete project. So these are some general documents, and if we look at the base image itself and the software that's being delivered for this particular container that we'll build now, we'll use the binary only delivery. So we'll change into this directory and have a look what's in here. So first of all, there's a little text file, license info binary delivery. So of course, whenever I get some software and I can find a file that says license info or licensing or legal info, then that's something interesting. So we'll just have a look what that exactly says. And here you can see the typical information that you would expect to be included with a delivery of open source software. This container contains free and open source software. We have a warranty disclaimer here, and then a little hint to where additional legal information can be found, which is in particular in the root directory of the container itself in this HTML file, legalinfo.html. And then in addition, because we are looking at the binary only delivery here, we have the source code offer as it is required by the GPL and can then be used for all other open source software which requires the source code to be delivered as well. So anyone can obtain the source code by writing to this email address. And of course here this is not filled out because this is a template, but if you are using the OSADL Docker Base Image, you will have to fill out this email address and this address to give the recipient a contact data where they can request the source code from. So here we would write info@osadl.org and then Open Source Automation Development Lab, our open source info department, and our address here in Heidelberg. So this is just the general license information. The same information is displayed again when starting the Docker container interactively. And then we have this additional archive here, the Buster source 1.2 tar gz archive, which contains all the material that's required for delayed source code delivery. So this contains the source code, this contains build instructions, and it also contains the license scan again, which is already available in the image itself, just so that it is complete in the place where it can be delivered on request. So if on this source code offer, if a request reaches you, you can then send this archive, which includes all the required information. So this is the legal information, and then here we have the base image itself, and as it says in the document how to get started, we can simply load this this image into our Docker installation on this computer, which I have. Of course, there is a Docker installation available here, so we do docker load and load the OSADL Docker Base Image binary only into our Docker installation. So as you can see, there's only one layer because, of course, it's only the base layer itself. And if we have a look at it now, we can see now the OSADL Docker Base Image DBM Buster in version 1.2 binary only is now available in our Docker installation. Now we have the base image available, and now we want to build a customary container on top. And to remember again the Docker file which we built this container from, I'll just get this Docker file on this slide so that you you remember this is the same Docker file that we just looked at in the presentation, but the presentation, it was shortened a little bit, but content-wise it is exactly the same thing. So here as well, we'll switch out of this into the directory where the Docker file is available. So we'll build this Docker container from this Docker file and we'll name it immediate C, and we'll build it within this from the Docker file located in this directory. And now we can see parallel to what is listed in the Docker file that is done here when building the container. So first of all, the OSADL Docker Base Image is used, the maintainer is labeled, and then the dependencies are being installed. And now the installation is running, and that will take a little while. And while the installation is running, we can already, oh, okay, so this is going fairly quickly. And just to give some outlook on what we'll do once the image is created, we'll have a little look into the image, because as I mentioned before, every single command within the Docker file here is turned into a new layer of the final Docker image. So now we're already one step further. So now we're already building the immediate C, and here already now the time high res dependency, and then the immediate C container is installed. And for every step in between, an intermediate container is created and then removed again. And here now the installation step is being done, and finally the individual setup that's required in the last step. And now we have an image that's created from our Docker file, and that can now be is now even listed in the Docker installation, as we can see here, immediate C, our new container image. And now it's quite interesting to inspect this container image. So we do Docker image inspect, immediate C. We only have one version, but just to clarify that we're looking at the latest version here. And that gives us some metadata on the container, just some general metadata on the container. And the interesting point that I would like to point out here is the number of layers that we have down here. And if you have a look at the number of layers, which are all given with a checksum here, so you have 1, 2, 3, 4, 5, 6, 7 layers within this container image. And if we look back at the Docker file, we can see we have the base image is layer 1, then we have the first installing dependencies is the second layer, downloading and building immediate C is the third layer, installing the time high res dependency is the fourth layer, installing immediate C is the fifth layer. In the presentation, building and installing were in one layer, but I've split it up here just to keep an overview. And then we have the sixth and seventh layer with setting up the SSH and cleaning up behind us. And then only this eighth layer will only be added when the container is actually started from this container image. So it is not available in here yet. So we have 7 container layers, and here we have 7 separate commands within the Docker file. So here you can see how these translate into separate layers. Now that we have created our container, we of course also want to run it and see if the application actually works. So we'll run the container. And as it is requested, it prints out some information about the network. The interesting information here is the IP address that we'll need in a minute. And then also, as I mentioned before, this Docker container also prints out, when started interactively, it prints out the licensing information or the legal information, including the source code offer again. So now the container is running. We'll go back to the host machine here and connect to our container via SSH. Use the normal port and use graphics. And here we need the IP address that's printed out here. And then start the exemplary application of the immediate C application. So that has a Hello World program that we'll use to test if the application, if the build has worked at all. And off we go. So the root password is root, as we've established in the Docker file, and now the immediate C is running in the container, and we can see it from our host machine here. And now we will build this application. It says hello, successfully built. We'll go live on the application and then run it. So this is just a little example of what this immediate C can do. As you can see here, we have a little button. If we switch that to high, then we see the live. This one variable that we have here is set to high, and we can set it to low again. And when we quit, we can also see that it has printed our hello world as we have switched it to high. So we have now started with the OSADL Docker Base Image. We've used a Docker file to create a customized application, to put a customized application on top of the OSADL Docker Base Image and create a container image from that, which we have run and showed that it works.
Now this was to show how an exemplary application can be built on top of the OSADL Docker Base Image, and you'll see that it actually worked. In the advanced lecture, Aber und Himmel will look at how to find out if you receive such a base image, if it can be made compliant, and how to check out if there are any issues with it. So before we get into that, let me quickly summarize. We have created an OSADL, a license-compliant container base image, to give you a leg up in creating container-compliant customized applications on top of this base image. And all of this has arisen from last year's Cool Talk and from the ensuing legal opinion by Dr. Till Jäger. Just a little note on this, the information that is given here is based on this legal opinion, but there's as of yet no case law with regard to Docker containers and license compliance. So different interpretation, in particular the idea that
no license obligations for base images are required, or even the idea that license obligations for distributing Docker files are required. There are different interpretations possible, could be arguable, but we recommend this interpretation that I presented here. And apart from this legal opinion, which is available for OSADL members on the OSADL website, you can also, it's very well worth reading this article by Armin Hehme, Docker Containers for Legal Professionals, which you can find at this link. Because a lot of the basic information that I gave in the beginning and a lot of the challenges that await us are very well presented in this paper. So I can highly recommend this. Read this, and I'm sure you'll see where the expertise comes from after listening to Armin in the following advanced lectures. Thank you.